Hello juniors, today we're going to continue with electronic assignment 15, which is about the binomial distribution. If you remember, basically we've seen the characteristics that need to be fulfilled in order to talk about a binomial distribution. We have seen some examples in order for you to understand and correctly interpret how the formula for binomial distribution works. If you remember, this is a formula for the binomial distribution, right? Remember, this NR is the combination of n trials taken R at a time times the probability of success to the power of R times Q, which is the probability of failing to the power of n minus R. If you remember from the easy example that we talked about, if we throw a coin three times, what's the probability of obtaining head, right? And we talked about a biased coin where the probability of obtaining head was 2/3, right? And from this analysis, we got to the formula, right? You see that 3 is the number of combinations in which I can obtain 2 heads and 1 tail. 2 heads, 1 tail. You see that there are 3 different combinations. Then the probability of success for head is 2/3 to the power of 2, which is how many times I want to obtain head. In this case, we wanted to obtain 2 heads in each case. And finally, the probability of failure, which is the probability of obtaining tail, in this case would be 1/3. And it's to the power of 1 because out of the 3 throws, I want 2 to be head and therefore only 1 will be tails, right? So this is, if you associate this with the formula, you will remember why it is like it is, right? N taken R at a time of P to the power of R times Q to the power of n minus R. N minus R. Minus R. That's the formula, right? Okay. So, now, today we're going to see examples, how to apply this concept of binomial distribution through different examples. We're going to see like 5 or 6 examples about this. Okay, so example number 1 says the following. X is binomially distributed with 6 trials and the probability of success is equal to 1/5 at each attempt. What is the probability of exactly 4 successes, at least 1 success, or 3 or fewer successes? Okay, so first of all, we need to identify our information, right? If I write the formula here, we're going to say that a binomial distribution, the probability is found by doing the following. N taken R at a time of P to the power of R times Q to the power of n minus R. This is a formula we talked about for binomial distribution. So what do we have as an information? 6 trials. 6 trials corresponds to the value of n, right? This is how many trials we have, so this is n. And then we have a probability of success, it says. So this value, 1/5, corresponds to the value of P, right? The probability of success. Okay, so with this information, we can start the problem. For part A, it says, what is the probability of exactly 4 successes? If we're talking about 4 successes, this 4 over here is representing the value of R in our formula, right? It's the number of successes that I want. So in this particular case, if I zoom in here, 4 is the value of R, okay? So we're going to say that for part A, R is equal to 4, right? And I'm going to show you 2 ways of solving this. First of all, we're going to do this by hand, and then I'm going to show you how to do it using the calculator, okay? So if we do it, let me write here, by hand. If we do this by hand, then we're going to say that the probability of X being equal to exactly 4, the probability of obtaining 4 successes, if we respect this formula, I'm changing this to maybe blue for you to remember. And I'm going to frame this. This is our formula. Yeah. Okay. So probability of getting exactly 4 successes would be 6 trials n taken 4 at a time times the probability, which is 1/5 probability of success, to the power of R, that's to the power of 4, times a Q, which is the probability of failing, which in this case would be 4/5, right? If success is 1/5, then failing is 4/5 to the power of 6 minus 4, the remaining attempt we have. Okay, so we need to solve this. Remember, we're doing this by hand. So we need to calculate this combination. If you remember the formula for combination, let me write that here as well. The formula for combination is the following. NCR is equal to n factorial divided by r times n minus r factorial. Okay, so that's exactly what we're going to do in order to find the number of combinations. So we're going to do 6 factorial in this case divided by 4 factorial times 6 minus 4 factorial. And we need to calculate this. 6 factorial is the same as saying 6 times 5 times 4 times 3 times 2 times 1. This is being divided by 4 factorial, which is 4 times 3 times 2 times 1, times 6 minus 4, that's 2, and 2 factorial is 2 times 1. 2 times 1. So I see that I can simplify, for example, all of this with all of this. And what do I have left? I have left 6 times 5, which is 30. And this is being divided. Let me write this down to have more space. So we're going to say that 6/4 is equal to 30 on top, on the numerator, divided by 2. And 30 divided by 2 is 15. So that's the value, the number of combinations, if we have 6 trials taken 4 at a time. Okay. So now, if we go back to the formula again, the probability of x being equal to 4 would be 15, right? The number of combinations times the probability of success, which is, I already have this written here now that I see, so I'm going to copy this. Probability of success and the probability of failing, right? 6 minus 2, we can write this as 2 already. So we need to solve this. If we solve this, this would be equal to 15 times 1 over 5 to the 4th power, that's 125, 625. And this is being multiplied by 16 over 25. 16 over 25. If we multiply all of this, well, in this case, we will need to use calculator, right? Because we're getting big numbers. But I'm going to write the result just to save some time. The probability of x equals 4 would be 48 over 3,125. And this, if we approximate to a decimal number, is 0.01536. So this is the probability of obtaining exactly 4 successes in this particular situation, okay? Now, I'm going to show you how to do this same process, but now using your calculators. So if you can have your calculators with you, I strongly recommend you to do so, because I'm going to show you some new things that you still haven't seen. So I'm going to write here, I'm going to do the same problem, but now using our graphic display calculator. Okay, how do we do this in the graphic display calculator? I'm gonna show you the calculator, and then I'm gonna write the steps here, and I'm gonna finish the problem. So if you have your calculator, well, you'll probably be in the first menu. I'm gonna erase this. In order to do binomial distribution, we would go to menu, statistics, number 2, and then we'll go to dist for distribution, right? Remember, we want to find out binomial distribution, so we're going to click on dist, which is F5. And here we have the option for binomial, you see? So we click on F5 again. And then we have 3 options here, which I'm going to be explaining a bit further in the next problems. But basically, BPD is whenever we want to find the value of an exact number of successes. In this particular case, we're going to apply BPD because we want exactly 4 successes, okay? And BPD, just for you to know, stands for binomial probability distribution, okay? Then we have BCD, which stands for binomial cumulative distribution. And this case will be used, for example, if we are told find the probability of at least 4 successes, right? So in that case, we do not only contemplate probability of 4, but we also need to contemplate probability of 5 and probability of 6, right? Because we're talking about 6 trials. So whenever we have more than one probability that we need to consider, we're going to be using binomial cumulative distribution. And finally, inverse of a binomial is used whenever we have the probability, but we want to determine, for example, the value of r, or any other value, and we're given the probability, okay? We're going to see how to apply each of these options in the other examples. But for now, as we want to find the probability of exactly 4 successes, we're going to use the first option, binomial probability distribution. So we click on F1. So here you have, your calculator would normally say data list, and you need to change this to a variable. Let me see, if we click on F2, yes, you need to click on F2 and it should say variable, okay? Then for X, you need to put the number, the X would be the same as the R in our problem. For the number of successes in this particular case is 4, right? So X is equal to 4, right here, 4, there. Then number of trials, in our problem we have 6 number of trials, right? So that's the value of n. And the probability P is the probability of success, right? So we're going to write 1 divided by 5. 1/5 is our probability of success. So once we put all of the value, we click on execute. If you go to last, click on execute, and here you have the probability, which is 0.01536, which is exactly the value that we obtained in the problem. Okay, so that's how we do it in the calculator. If we go back to the electronic assignment, then I'm going to write the steps for you to remember. You first of all need to go to menu, stat, then you click on dist, then binomial, which in your calculator I think it would say bin, like this, for binomial. And then for this case, you're going to click on BPD, okay? And once you have that, you're going to see this screen, which is right here. And you need to fill in the information. X is the value of R, and a number of trial is the value of n, and P is the value of probability of success, which in this case is 1/5, which is 0.2. Okay, then you click on execute, and you get the probability, which should be the same as the one we calculated by hand. And this is what we got, 36, okay? So finally, we would say that the probability of X being equal to 4 is equal to 0.01536, which is exactly the same value we obtained by doing it by hand, okay? So that's how you do binomial distribution by hand, using the calculator as well. Okay, so that was only part A. I tried to explain everything, that's why we took a lot of time, but these exercises are actually done pretty fast. Let's go to part B. It says, find the probability of at least one success. At least one success means that I can have 1 success, 2 successes, 3, 4, 5, up to 6, because we're talking about 6 trials, right? So let me write this as probability of at least one success. So at least one success. This is equal to the probability of 1 success plus the probability of 2 successes plus the probability of 3 successes plus probability of 4 plus probability of 5 plus probability of 6. But you see that this is very long, right? If we calculated each of this and we added them all, then we're going to get the result, but this is going to take too much time. If you think about what probability of at least one success means, it's at least 1, right? Up to 6 in this case. So if we can shorten this just by saying that probability of at least one success is the same as saying 1 minus the probability of obtaining 0 successes, right? That's the same thing as calculating all of this, okay? So we're only going to do this, and we only need to calculate one probability, which is probability of 0 successes, and then subtract that value, subtract 1 with that value, right? So we're We're going to do the same thing here. We're going to calculate the probability of 0 successes using our calculator. If I show you my calculator again. In this case, if we want 0 successes, we need to change the x for 0. Number of trial is still 6 and the probability is still 0.2. So we click on execute and there we have the value. So it's 0.26144. Okay? So this is a result for probability of 0 successes, right? But we want to calculate the probability of at least one success, right? So probability of at least one success is equal to 1 minus that value, which is 0.26144, and this is equal to 0.738. So this is the probability of obtaining at least one success. You see that this value is kind of big, right? It's 73.4%. And it makes sense, right? Because here we have most of the different possibilities for success in this particular situation, right? Remember, you can do this also by hand. You can calculate this probability by hand. If you do this by hand, this is the same as saying, let me show you. All of this is the same as saying probability of 0 is equal to 6 taken 0 at a time of 1/5, which is our probability of success, to the power of 0 times probability of failure, which is 4/5 to the power of 6, right? If you calculate all of this, you should get this number over here is 1. There's only one combination. This probability is also 1. And this number would be 4,096 divided by 15625. And this also gives us 0.262 if we round this to 3 significant figures. Okay, so that's how you calculate it by hand, but it's not necessary if you can use your calculator. Okay. So that's it for part B, at least one success. Now we need to go to part C to finish this problem. It says for part C, the probability of 3 or fewer successes. 3 or fewer successes. So let's analyze first what this means. So probability of, let me write 3 or fewer successes. If we think about this, 3 or fewer successes is basically having 0 successes, or 1 success, or 2 successes, or 3, right? 3 is also included, right? 3 or fewer successes. So we need to calculate all of these probabilities and then add them all in order to have the final probability. Or we can do a shortcut, which I'm going to show you in a second, okay? So one way, the long way, I'm going to write it, long way, would be using GDC, and here we're going to use, I'm going to write it like this, again, BPD, which is the first option I showed you, and we're going to calculate using BPD, we're going to calculate the probability of 0, we're going to calculate the probability of 1, probability of 2, and probability of 3. All of them separately, right? If you use your calculators to find each of these, you just need to change the value of x, right? And you're going to get all of the different probabilities. So let me write the answer here to save some time. 0, we have already calculated that, 262. Probability of 1, it's 393. Probability of 2 is 246. You may try finding this with your calculators on your own. You should get the same values, 0.82. So once we have calculated all of the different probabilities, we're going to add all of this in order to find probability of 3 or fewer successes, right? So if we add all of this, 3 or fewer successes is equal to 0.262 plus 0.393 plus 0.246 plus, I don't have space here, plus 0.082. So if we add up all of these terms, we're going to get the probability of 3 or fewer successes. And this would be equal to 0.983. Almost 100%. So the probability of obtaining 3 or fewer successes in this particular situation is almost of 100%. Okay? Now, I'm going to show you the short way of solving this. Short way. As I told you, we have other options besides BPD, right? The short way would be doing the same, right? You're going to use GDC, but now instead of clicking on BPD, we're going to click on BCD, okay? And I'm going to show you that in the calculator. I'm going to go back to the main menu of statistics, which is this one. And we're going to go to dist again, binomial, F5. But now, instead of clicking BPD, we're going to click on BCD, binomial cumulative frequency. Click on F2. Again, this data should say variable. And then for lower, you need to make sure that for lower, in case it says lower. In some calculators, I think this option of lower does not appear, and neither. I think this upper does appear, but the lower, I'm not sure. I think that for you, you'll only get X in some of your calculators. In case you have lower and upper, for lower, you should write a very small number. For example, -9 to the power of 99, right? This is a very small number. And for upper, you're going to write, in this case, it says 3 or fewer successes, right? So you're going to write 3, right? It's the upper boundary. It's up to where I can get, right? And then for a number of trials, you're going to write 6. We have 6 trials, right? And the probability of success is again 0.2. So if you click on execute, you see that you get the same value, right? 0.9304, which is exactly the same value we got doing the long way, right? So let's go back to the assignment. So by doing the long way, the short way, we're gonna do we did the following steps: menu, stat. We click on dist again, binomial, but now we clicked on BCD, right? BCD. And by doing that, you're gonna get this screen over here, where, as I told you, in some calculators, instead of getting lower and upper, you're just gonna get X. And if you have X only, you're just going to write 3, okay, in this particular problem, because the upper boundary is 3, right? Because we want to get 3 or fewer successes. It all depends on what the problem states, okay? So once you plug in all of the value, you click on execute, and then you get the result, where the result is probability of at least three or fewer successes is the same as saying X being less or equal than 3, right? That's probability of 3 or fewer successes. So this is equal to, and we got the result, 0.983. We got the same result we got by doing it by hand, okay? So I think we're gonna leave it here because I don't want to make this video too long. I hope this is getting clear for you people. Next class, I'm gonna show you some more examples about binomial distribution for you to finish understanding this better. But I think it's easy, right? You just need to be able to identify the different variables, N, P, R, and with that information, it's easy to solve, right? It's just plugging in the information into the formula in case you not use a calculator, or you plug in the information into a calculator in case you can use it, okay? So I hope this was clear. If not, please let me know and we will clear doubts in future live sessions. See you.